Hello students, in our previous class we had discussed about discovery of the subatomic particles like electrons and protons, and later on we discussed about the proposed atomic model by eminent scientists like J.J. Thomson and by Rutherford. We were discussing about the drawback of Rutherford atomic model as proposed by Rutherford, that the proton occupy the center of the sphere and the electrons are revolving around the nucleus in a circular path. And as we had discussed, that whenever a charged particle like electron revolves around in a circular path, then they accelerate and at the same time they radiate energy, and due to which they execute a spiral path and eventually they will jump into the nucleus. As the nucleus contains proton that is positively charged, when the electrons jump into the nucleus, they will discharge and that will lead to instability of an atom. So he could not explain the stability of an atom. That was the drawback of Rutherford atomic model. As I emphasized, this was the case arised, or this was the objection that was raised for Rutherford atomic model, that whenever electron revolve around the nucleus in a circular path, then they will execute a spiral path that will lead them to jump into the nucleus. So in the year 1913, one eminent scientist overcome this drawback of Rutherford atomic model. Basing his observation on Rutherford atomic model, he proposed another atomic model, and he is none other than your both Niels Bohr, and he proposed his atomic model in 1913. What was his observation and what was his proposal for the atomic model? He proposed that only certain special cells, that is orbits known as discrete orbits of electrons, are allowed inside an atom, and while revolving in the discrete orbits, the electrons do not radiate energy. What does that mean? That means around a nucleus, when electrons are revolving, they are not revolving in any random path. Rather, there is a special path in which electrons are allowed to revolve around the nucleus, and this orbit or path is called as your energy cell. And while revolving around the nucleus in this specific path, they do not radiate energy. So let's look at a diagram. As this is a center, if you see, the first circle indicates the first energy cell or the first orbit where an electron is allowed to move, and it is named as K cell, and there is a numerical value assigned to it which we denote as small n is equal to 1. The next energy cell around that nucleus where electrons are allowed to move is your L cell, and where the n value for the L is 2. The next higher energy, as we go further away from the nucleus, the energy of this cell or this orbit gradually increases. So we can say K, as it is nearer to the nucleus, will have the lowest energy. As we go far away from the nucleus, the energy gradually increases. So the next cell after your L is your M cell, where the n value is 3. The next higher cell is your fourth cell, that is N cell. Here the value is 4. So we can arrange them as K, L, M and N, and it can go on further like 1, 2, 3, 4, 5, so on. So here what we can say, when electron is revolving in K cell or in L cell or in M cell or in N cell, they do not radiate energy. That means for the lifetime they remain in the same cell and they revolve around the nucleus. As it is a similarity you can observe here to the planetary model, as the planet in our solar system are revolving around the sun in a fixed path, they do not change their path. The same way, in an atomic model of Niels Bohr, the electrons also do not change their path while revolving around the nucleus. And as we had discussed in Rutherford atomic model, that while revolving around the nucleus, the electron may execute a path such as spiral path. This drawback was overcome in case of your Bohr's atomic model, as he said that while revolving around the nucleus, the electrons do not radiate energy. So this, in the sense, we can say he overcome the drawback that was present in Rutherford atomic model, and it was widely accepted. Looking at the next, if you can see, this is how what happens in case of your Niels Bohr atomic model. Electrons are revolving, if you can see, around that central dot, that is a red dot representing the nucleus, and the electrons are revolving around the nucleus, and they are in the same path throughout their life. So this is what we can say about Niels Bohr atomic model, or otherwise famously known as Bohr's atomic model. So here at this point we will discuss about another subatomic particles, because till now in this chapter we have discussed about the discovery of electrons and protons, and whatever atomic model we have studied, the structure of atom has been discussed or explained on the basis of only these two subatomic particles, that is the electrons and proton. But in the year 1932, another subatomic particles was discovered in an atom having a neutral charge. Unlike your electron and proton, electron negatively charged, proton positively charged, this subatomic particle has no charge, and this was discovered by a British physicist known as James Chadwick, and he discovered this neutral particle inside an atom which is present along with the proton in the nucleus, and for this discovery James Chadwick was awarded with Nobel Prize in Physics in the year 1935. And if you look about the properties of neutron, as I mentioned, it has no charge, but its mass is equal to a mass of a proton, almost equal to or almost equivalent to the mass of a proton. And if you observe about all the atom contains a proton, except there is one exception you will find. In case of hydrogen atom, hydrogen is the only atom where it does not contain any neutron, it only contains one proton in its nucleus. Rest all the elements in their atom, they contains proton. The mass of an atom is therefore given by the sum of the proton and the neutron present in the nucleus of an atom. As along with proton, neutron is present in the nucleus, later on after the discovery of neutron in the year 1932, the way atomic mass was viewed, that was changed, as in the nucleus a neutral particle, that neutron is present and which is having almost equal mass as that of proton. So now as we know, the mass of electron is highly negligible, so the mass of an atom is due to the mass of proton and the mass of neutron. So dear students, now you know there are three subatomic particles. Electron was discovered by J.J. Thomson, proton was discovered by Goldstein, and your neutron was discovered by James Chadwick. Now these three subatomic particles gives rise to the structure of an atom. And the three famous atomic model that you saw was J.J. Thomson atomic model, Rutherford atomic model, and Bohr's atomic model. And Bohr atomic model was widely accepted because it explained the stability of an atom. It overcome that exception or that drawback that was present in case of Rutherford model, and that's why it was widely accepted. So dear students, now let's see how electrons are distributed in different cell of different atoms. There are certain rules by which we can distribute electrons in different orbits. Let's have a look. The maximum number of electrons that can be accommodated in a given cell is given by the formula 2n square, where n is the orbit number or energy level index, such as 1, 2, 3. For K cell it is 1, for L cell it is 2, for M cell it is 3, and for N cell it is 4. So let's see how many maximum number of electron can be accommodated in the given cell like K, L, M, N. The first cell, if you see K cell, by the 2n square formula, 2 into 1 square, that is equal to 2. For the second orbit or for the L cell, we can have 2 into 2 square, that is 8 electrons. For the third orbit or M cell, the formula by 2n square, 2 into 3 square, that will be 18 electrons. And for the fourth cell or N cell, that will be 2 into 4 square, that is 32. So let us summarize how many maximum electrons that can be accommodated in a given cell. For K cell it is 2, for L cell it is 8, for M cell it is 18, and for N cell it is 32. What other rules are applicable while distributing electron in different cell or in the orbit? The second rule is here, the maximum number of electrons that can be accommodated in the outermost orbit is 8. So whenever we go for the last cell of an atom, we can maximum accommodate 8 electrons, although the capacity may be beyond 8, but the maximum electron that can be accommodated in the last cell will be 8. For this, we'll have a specific example and later on we'll explain it. The third rule is your electrons cannot be accommodated in a given cell unless the inner cells are filled, that is, the cells are filled in a stepwise manner. What does that mean? That means to fill up the electrons in L cell, K cell must be completely filled. Similarly, to fill up the M cell, L cell must be filled first, then only we can accommodate an electron in the M cell. That means the filling of electron always takes place stepwise manner. First K cell, then L cell, then M cell, then N cell. So let us try to understand the distribution rule by taking certain specific example. The first example in front of you is a hydrogen, and as all of you know that hydrogen has only one electron. So as it is having only one electron, that particular electron will be accommodated in the K cell. So hydrogen contains one electron and that electron is accommodated in the K cell. Similar way, let us take another example, that is your helium. As you know, helium is having 2 electrons and that 2 electron will be accommodated in the first cell, that is K cell. And as you know, K cell can have maximum 2 electrons. So here we can say the outermost cell of helium, that is only one cell, and that is also completely filled. And due to this complete filled configuration, helium is highly stable in nature and it do not react with any other element to form compounds or to form molecules. And that is why helium is categorized as an inert gases or noble gas. Let us take another example to understand it with more clarity. That is your carbon. As you know, carbon contains 6 electrons. And how these 6 electrons are distributed? The first cell, that is K cell, it can have maximum 2 electrons, and the remaining 4 electron goes to the L cell. So we can say in carbon the electronic distribution is 2, 4, that is in K cell 2 electron and in L cell 4 electron. So here for carbon, the outermost orbital is your L cell and which contains 4 electrons, and the innermost orbital or inner cell is your K cell containing 2 electrons. So let us take another example so that we can understand how M cell and N cell are filled up. So here is another example, that is your sodium. As you know, sodium is having 11 electrons, and how it is filled? The first cell is your K, 2 electrons. The second is L, 8 electrons. As you know, in case of L cell, by 2n square formula, the maximum number of electrons that can be accommodated is 8. So the L will contain 8 electrons and the remaining will go to the M cell, that is 1 electron. So the electronic distribution in case of sodium is 2, 8, 1, and the outermost of sodium contains only 1 electron. Coming to the next example, and the crucial example is your potassium. If you look at potassium, the distribution, as you can see, K is having 2, L is having 8, M is 8, N is equal to 1. One question that arises in our mind here is that why M contains 8? By the 2n square formula, the number of electrons that can be accommodated in M cell is 18, because M, the n value is 3, so 2 into 3 square is 18. But here if you see at the diagram, M contains 8 electrons. Why is it so? If you recall the rule, the maximum number of electrons that can be accommodated in the outermost cell is 8. If I accommodate try to, although the capacity of M is 18, but if I here by the distribution if I go, one of the possible distribution will be 2, 8, 9. But as you know, 9 electrons cannot be accommodated in the outermost cell, and because of that M will contain 8 electrons and another electron will go to the N cell, and that is why the correct electronic distribution in case of potassium will be 2, 8, 8 and 1. So this is very important, you must take care of it. So dear students, let's have a look at a table where we'll have a list of elements and their distribution of electrons. And this table is also given in your NCERT textbook. Refer to it for all those elements that we have not discussed here. Some of the example we discussed. So here if you can see argon, chlorine, sulfur, phosphorus, silicon, aluminum and rest, there are 18 elements are given in this table, and this is what can help you to understand how electrons are distributed for different elements. Now let's summarize what we have studied today. So we have studied about Rutherford atomic model, drawback of Rutherford atomic model, and about Bohr's atomic model, and how electrons are distributed in different energy cell. So dear students, here is a question for you. Draw a sketch of Bohr's model of an atom with 3 cells where the outermost cell contains 3 electrons. Let us try to understand this question. We will draw a Bohr's model of an atom having 3 cells, that is K, L and M, and the outermost cell, that is M, will contain 3 electrons. I hope you can draw it. Let's see the answer of this question. So let's look at the answer. So this is the nucleus, and around the nucleus we will have 3 cells. The first cell will have the K cell containing 2 electrons, the L cell containing 8 electrons, and the outermost cell, that is M cell, containing 3 electrons. So the distribution will be K 2 electrons, L 8 electrons and M 3 electrons. So total 13 electrons, and as you know 13 electrons are present in the atom of aluminium. Let's have a look at another question. If K and L cell of an atom are full, then what would be the total number of electrons in the atom? I guess you can answer it. K and L cell are completely full. By 2n square formula, the maximum electron that can be accommodated in K is 2, and the maximum electron that can be accommodated in L is 8. So the full capacity of K and L are 2 and 8 respectively. So the total number of electrons will be 2 plus 8, that is 10 electrons. So the answer to this question will be 10 electrons. So total 10 electrons are present if K and L cell of an atom are completely full. So we'll take another last question, that is write the distribution of electrons of an atom containing 17 electrons. So we'll be distributing 17 electrons in different cell. Here 17 electrons, so the first cell will have 2 electrons, that is K is equal to 2. Then the second cell, L cell, that will contain 8 electrons. So 2 plus 8, 10. The remaining is 7 electrons. So the remaining 7 electrons will go to the M cell. So the distribution of electron will be as such 2, 8, 7. That is K cell contains 2 electron, L cell contains 8 electron and the M cell contains 7 electrons. So I think from all these questions you have clarified your concept related to distribution of electrons in different energy cells. Practice few more questions, that are given in your NCERT textbook. Go through the chapter thoroughly. Take care. Thank you.